All right, last example here. So, in circle A, the radius is 5. BD is 8. What is the length of AD, and what is the length of AE? Okay, so we have this circle, we have this setup here, and we should notice we've got this right angle. Okay, that's going to be a pretty important piece in this particular problem. Okay, so first question, let's just dive in. What is the length of AD? Okay, so A to D. All right, what is that length there? Now, notice there's not even an actual line connected there, but that doesn't mean we can't find the length. Okay, so something, it's just something to keep in mind, right? We can still find that length even though there's not a actual little line. Okay, so let's think about it. Okay, this one's a little bit weird if you're not comfortable with it. Okay, but let's look at the information we're given. Okay, and we have that the radius is 5. Okay, well, what is this length here? Right, so this is the center, this is the edge. Right, and that's the definition of the radius. Right, the radius is that length from the center to the edge. So this length right here is also 5. Okay. All right. Now, and just side note, a more like natural probably way of seeing the radius, right, would just be A to C was already there. So maybe you're just so kind of used to just connecting that length, right, that's the radius, but that's not the only radius. Okay, so just something to remember. Any length from the center to the edge is also that same length of whatever the radius is. So there you go on that one. That's AD. All right, let's look at AE. So AE is this little length right here. All right, so this is a tough one. All right, this is a tough one right here. So, but one piece that we can try to kind of the big connector, right? This is the big problem-solving tool to use here is actually to use this right triangle right here. Okay, right triangles are important; they have their applications. Okay, so we now know that this length is 5, right? Because we got it from the previous one. All right, and something to consider is if we had this length from E to D, then we can find that AE. All right, now here's why. Well, if we have two lengths out of the right triangle, then we can use the Pythagorean theorem and we can find AE. So now the problem becomes trying to find ED. All right, so what is ED? Well, do we know anything about ED? Well, let's look at the other piece we know. Okay, look at that. BD is 8. Okay, so B to D is 8. That entire length is 8. All right, and there's probably got to be some kind of connection to this and this. Okay, well, the connection is that we're basically going to use that property number 2, which is saying that diameter, if it's perpendicular to a chord, then it bisects that chord. So if I have something that is perpendicular, okay, a radius here in this particular one, then it splits this entire thing in half. Therefore, this and this are the same. So that's exactly what we have here. This and this are now the same because of that right angle. And since that's the case, we know that B to D, we know that length is 8. If it's split in half, that means just this is 4, and just this is 4. Okay? So now we have this right triangle, and we're going to use the Pythagorean theorem to find AE. So I'm going to go ahead and redraw that triangle just for good measure to be able to see it a little bit more. So this is 5, this is 4, and I'll go ahead and call this X. Okay? So again, we have 2 out of the 3 in the right triangle, which means 2 out of the 3 side lengths, I should say, of the right triangle. Therefore, we can use the Pythagorean theorem to find that third one. Okay, so I've got a squared plus b squared is equal to c squared, okay, where c is my hypotenuse. Okay, now I just set this up as x, right? AE, once we find x, we have AE, right? Those two are the same, okay? So A and B don't matter, right? These are interchangeable, but C has to be the hypotenuse, okay? So I'm going to go ahead and set this one up as x, right? X squared plus 4 squared is equal to 5 squared, okay? Can't do anything with this x squared, so I'm just going to bring it down, okay? Remember, we always want to work down with the Pythagorean theorem. 4 squared, that's 16, okay? 5 squared, that's 25. And if I can isolate x squared, then we basically take the square root, and we're done, okay? So our goal is to isolate x squared. Right? When you see x squared, when you're trying to solve it, typically you want to isolate it in order to find what it is. All right, so minus 16 I've got x squared is equal to 9. From here we take the square root on both, and I get that x is 3, which means that AE is 3. Okay? And there's that one. Unfortunately, this is the second time I had to do this one because I lost the other video. Cool. Anyways, you guys have a great day. Take care. See you later. What's going on?